Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Pacify 2 Surrounded by Samu Piano. And here are the rules. Normal Sudoku rules apply, which means place one digit in every cell in this grid from the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have blue cages are pacifist cages, which are the opposite of killer cages, where digits can repeat in a cage, and the set of all digits in a cage, not including repeats, cannot contain any subset which sums to the number in the top left corner of the cage. For instance, if we have a 5-cell pacifist cage with 18 in the corner, could be, so let's just construct a pacifist cage. Let's just say this is a pacifist cage here. And it has an 18, let's say it had 18 in the corner. Then it could be, for example, 9, 1, 2, 3, and 9 as the set. As the set 1, 2, 3, 9 does not have a subset which sums to 18, even though 9 plus 9 equals 18. Okay, so the subset cannot ever add up to 18. Or the sum in, or the digit in the corner, right? So, for example, another example, like for example, this 9. The three digits in this subset cannot add up to 9 in some sort in the subset, right? So obviously 9 is ruled out because 9 by itself would add up to 9. 1 and 8 together would be ruled out. 2 and 7 together would be ruled out. 3 and 6 together would be ruled out. 4 and 5 together would be ruled out. 1, 2, 6, if there were all three of those, would also be ruled out. So again, this is the opposite of killer cages, right? So the digits can repeat, and the set of all digits in the cage, or the subset of all digits in the cage, the set of all digits in the cage cannot contain any subset which sums to the number in the top left corner of the cage. And that subset could even be a single digit, right? Or it could be all the digits. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so that's interesting. We have, this is an interesting cage here, right? Because here, none of the digits can add up to 10. That means we're guaranteed you cannot have 1 and 9 together. You can't have 2 and 8 together. You can't have 3, 7, or 4, 6 together. We know there are 5 unique digits in this cage because they have to be here. And that's the maximum you could have, right, of unique digits. Because you have 5, and then you have 1 each of 1 out of 1 or 9, 1 out of 2 or 8, 1 out of 3 or 7, 1 out of 4 or 6. So we know a 5 is here. We don't know where it is. We have 1 out of 1, 9, 1 out of 2, 8, 1 out of 3, 7, 1 out of 4, 6. So because we have a 5 here, we cannot have, well, first of all, you can't have 1, 2, 3, 4, because that would add up to 10 by itself. If you had 2, 3, and 5, that adds up to 10, or 1, 4, and 5, that adds up to 10. So those don't count either. But we're not sure what else we have, right? This cannot add up to 3. This can't be 1. So that's interesting. This can never add up to 9. So 9 has to be one of these 5 digits here. This can't add up to 9, so 9 has to be one of these 6 digits here. So 5 cannot be here. These are all unique. So these have to match essentially these 3 digits. Three out of these 5 must be in these 3 digits, and 3 out of these 5 again must be in these 3 digits. To add up to 8, you cannot have an 8. You could have a 4, as long as it's not 1, 3, and 4 added up. What else do we have? So the 10s are the easiest to actually sort of see what they can be, right? So this is either 5 and 3 out of one of the 1, 9, 2, 8, 3, 7, 4, 6 subsets. Or it's all 4 of the subsets, right? 8 cannot have an 8, obviously. So 8 actually has to be one of these digits here, and then one of these digits here, and then one of these digits here. That's interesting. Because 8 cannot be... Oh. And then we can use Fistimafel's ring. So 8 cannot be in any of these digits here, which means 8 cannot be in the corner 2x2 areas. So we know there's an 8 in one of these 4 areas. There's an 8 in one of these 4 areas. And there's an 8 in one of these 4 areas here. What does that tell us? I'm not really sure. Obviously this can't be 3 here. So 3 has to be one of these. What else do we have? You have 5 unique digits here. You can't have 7 be there. You can't have 1 out of 1 or 6, 1 out of 2 or 5, and 1 out of 3 or 4 there. Right? Because... so that eliminates 7 and then 3 other digits. So therefore, we know what this has to be. This cannot have an 8 here. 8 has to be one of these 2 digits here. And then we have to have a 9. So this must contain a 9, and it has to have something out of 1, 2. So 9 has to be on this Fistamafel ring because it's in here. One of these 3. Actually, it could be here. Never mind. That's not guaranteed then. So 7 cannot be in this. We know 8 and 9 both have to be. And then 1 out of 1, 6, 1 out of 2, 5, and 1 out of 3, 4 are in this cage. Because otherwise, if you have 2 out of 1, 6, you would have, they add up to 7. You can't have 1, 2, and 4, though. You could have 1, 2, and 3. What else do we know? The 8 cage can have a 9 and a 4 in it. And those are both okay. The 4 is okay as long as it's not with 1 and 3. We know there's 5 digits in it, though. There are 5 digits in it. So, one of the digits, then 3 of the digits have to be 8, 7, 8, and 9. Sorry, not 7, 8, and 9. 3 of the digits in this 8 cage have to be 9 and 4. 2 of them have to be 9 and 4. The other 3 are digits from 1, 7, 2, 6, or 3, 5. So this has to contain a 9 in it then. For every set of 5 digits, right? You have to have a 4, you have to have a 9. And then you can't have an 8, and you have one digit from 1, 7, 2, 6, or 3, 5. So this must have a 9 and a 4 in it. All the way through, right? Therefore, 9 cannot be here, and 9 cannot be here. 9 cannot be here, and 9 cannot be here. Because we know that this has to be 4, 9, right? 4 cannot be here, 4 cannot be here. That's interesting. You can't have 3 digits adding up to 5, so you can't have 1, 2, and 5. Okay. So 6 obviously can't be here. So what digits are missing is kind of a question here, right? So we have 1 out of 1 and 7, 1 out of 2 and 6, and 1 out of 3 and 5. But you can't have specifically 1, 2, and 5 be the set with a 4 and 9. I'm going to pause. I need to go to the bathroom. I'll be right back. And I'm back. Okay. Let's continue. We know... Okay, so 9 in box 3 has to be either here or here. That's actually very interesting. We know all 4 of these digits must be in the ring here. So since those 4 digits must be in the ring, because by Fistemafel's theory, the central ring surrounding the center box must be exactly the same digits as the 4 corner 2x2 areas. So this 2x2 area, I don't know how you would solve this without Fistemafel's. It'd be probably pretty hairy without it. But these 4 digits must be then in the central box. So if one of them is a 4, we know that one of these is a 4. Since one of these is a 4, where is the 6? It can't be in the 10 cell, because that would be with the 10, and therefore 4 and 6 would add up to 10. It can't be in the 6 cell, so it must be in this cell here. So this must have a 6 in it, which means 6 cannot be here. 6 cannot be in the 8 cell, so that means none of the corner cells can contain 6. So that means 6 has to be here, because 6 can't be here. Since 6 is here, 6 has to be one of these 2 cells, which means 6 can't be here. 6 has to be one of these 2 cells. Because again, 6 cannot be in the Fistemafel ring. Because actually that's not true. Ooh, that's bad. Okay. We know there's a 4 in it, so 6 has to be here. But we don't know if 6 is... No, 6 actually cannot be in the Fistemafel ring. Because if 6 is in the Fistemafel ring, it would have to show up here. And we know 6 can't be in this one because of the 10 pacifist cage. So 4 and 6 would add up to 10. 6 can't be here because it would add up by itself to 6. So 6 has to be here. Or here. It could be here. Oh. Okay, that's not guaranteed then. So we know 4 can't be here. So 4 has to be one of these 4 or one of these 4. This actually could be a 6 here. Okay. So you cannot have 1 and 3 here. That would add up to 8 for these, for that subset. You could have 1 or 3. You could technically have 6 still in this Fistamifel ring. So being this could be 6. Okay. So you're missing 1 out of 1 or 7, 1 out of 2 or 6, and 1 out of 3 or 5. Okay. We know there's a 9 in the ring, but we don't know how many is the question. So 6 is one of these 3 digits, we know for certain, but we don't know which one it is. Whatever these 4 digits are. So these 4 digits and this digit are the 5 digits that are in the Fistamifel ring. Okay, so that's guaranteed. So this one, and I guess we'll mark it there. This is pink. Well, we know these are part of the Fistamifel ring. These are not. Obviously, none of these are. These have to be the same digits. Oh, that's interesting. What does that tell us? Well, we know 8 is one of them. And we have 1 out of 1, 7, 1 out of 2, 6, and 1 out of 3, 5. What you cannot, though, have is 6 and 7 in the same one. Right? Because if you have 6 and 7 in these 4 cells, the problem is that that would guarantee... No, sorry, 5 and 7 cannot be in both of these. So if you had 5 and 7 in both of these... What? Okay. Where is the 3 in column 7 and row 7? 3 can't be here. Assuming 3 was not in the Fistamifel ring, you couldn't have a 3 here or here, which would guarantee that a 3 would have to be here or 3 would have to be here. No, sorry, it'd guarantee a 3 has to be here and a 3 would have to be here, and therefore we would have a duplicate in column 9 of 2 3s, right? Because 3 can't be here because that would by itself add up to 3. 3 can't be here because it would add up to 3 by itself again, and we're assuming 3 is not on the Fistamifel ring. So if 3 is not on the Fistamifel ring, that means it can't be here, it can't be here, so it's guaranteed to be here and be here, which is a contradiction. So 3 has to be on the Fistamifel ring. So since 3 is on the Fistamifel ring, 5 cannot be, because 3 and 5 add up to 8. Therefore, 5 cannot be on the Fistamifel ring. 5 has to be one of these digits here, and one of these digits here, and one of these digits here. And therefore, it cannot be in the middle. It has to be one of these 2 digits here. That's interesting. Okay. So 5 is not in this 10 cell. We have at 1 digit then from each of 1, 1, 9, 2, 8, 3, 7, or 4, 6 in this 10 cage. We have 4 out of 4, 6, obviously. We do not have 8. 8 cannot be in this 10 cage because it would be on the Fistamifel ring. So we need a 2 then correspondingly. So 2 is in this Fistamifel ring because 2 matches here. 2 has to be all in this pacifist cage. Therefore, 6 cannot be because that would add up to 9. So we need 1 or 7, 3 is in this cage, so this has to be 3 then. Because, well, this could be 3. Never mind. So this is, we know a 6 is here then. 6 has to be here, which means 6 can't be here. 6 has to be here. 6 has to be here. 6 has to be here then. Okay, so then we're missing 1 out of 1 or 7. We're not sure which ones those are. Okay, so let's fill this in. This is 2, 3, 4, 9, and then 1 out of 1 or 7. This has to have 2 and 4, and then 1 out of 1, 9, and 1 out of 3, 7. We're not sure which. One of these is a 5, because we need a 3. Do we need a 3? We don't. We do need a 3. Ah, bingo. Okay. Right, again, because this can't be 3 and this can't be 3. If we assume this was not a 3, then 3 would be here and here, leading to a contradiction. Therefore, 3 has to be in this ring. 1, 3, and 4 add up to 8. So 1 cannot be in this ring. This has to be 2, 3, 4, 7, and 9, which leaves this as 2, 3, 4, 7, and 9. That leaves everything not on the fist fell ring as 1, 5, 6, and 8. So we know exactly what's not on the fell ring. It's 1, 5, 6, and 8. Okay. So that means we have 1, 5, 6, 1, 5, 6, 8 here. The rest in the middle, in the corners, are 2, 3, 4, 7, 9. Okay, so what does that mean? We know we need an 8 for this 7 cage, so 8 cannot be either of these. 5 has to be, oops, 5 has to be in this 10 cage to not add up to 10. This is 2, 3, 4, 7, 9. This can't be 6, obviously, so 6 has to be one of these 2 digits, which means this can't be 6. So 6 has to be one of these 2 digits, which means this can't be 6. So 6 has to be one of these 2 digits, which means this can't be 6. Therefore, 6 is one of these. 6 cannot be added with 1, otherwise they would add up to 7. So this can't be 1, which means this is 1. So this can't be 1 here. That means 1 has to be here, 1 has to be here, which means this can't be 1 here. That means 1 has to be here, which means 1 can't be here. Well, if this were 1 and 5, that would add up to 6. So this can't be 5. This is a 1-8 pair then. So we have a 1-8 pair, which eliminates 1 and 8 in the rest of the box and the column. So this can't be 8. This is a 5-6 pair. This 5-6 pair eliminates 5 and 6 in the rest of box 1. So this can't be 5. This is 1. This can't be 1 or 5. This is 8. So that eliminates 8 here. This is a 5-6 pair, which eliminates 5 and 6 in the rest of the box. This is a 1-8 pair then, which eliminates 1 and 8 in the rest of the column. So this is 6, and this is 5. This can't be 5 for the same reasoning. So we have 5. Out of the digits that add up to 7, we need a 9, and we have to have 1 out of 1, 6, 1 out of 2, 5, and 1 out of 3, 4. Well, then this must be a 6. This can't be 6. This has to be 5. So 1 out of 6. This 1 out of 2 and 5, and therefore this must be 2. So this can't be 2. We can't have a 7, obviously. So we have a 2 here, which means 2 cannot be here. This is a 5-6 pair. This is a 1-8 pair. 5 must be in the set here. We have 2, 3, 4, 7, or 9 here. This is 8. we have to have, it cannot have a 1 here. So where is the 1 in column, in this box 4? Can't be here, can't be here, can't be in the box because we have a 6 there. Or sorry, can't be in the cage because we have a 6 there. So this has to be a 1 here. 1 can be any of these 3. We don't know which. This is 5. 1 cannot be here. 1 could be any of these. One out of 3 or 4 is here. So this has to be 2, 3, 4, 6, 8, or 9, right? This is also 2, 3, 4, 6, 8, and 9. 8 cannot be here. 6 cannot be here. This can't be 9 because we need the 9 in this cage. 7 does have to be one of these 2. And we have the other 3 or 4 here. This cannot be 2, 3. Obviously, this can't be 9. And you cannot have a 2, 3, and a 4 here because that would add up to 9. You can't have 2 with... So therefore, 7 has to be here. Because you can't have 2, 3, 4. And if you have a 7, 7 and 2 add up to 9. So this can't be 2. This is the 3, 4, 7 triplet, which eliminates 3, 4, 7 in the rest of the box. Therefore, this can't be 3, 4, or 7 also. It's 2 or 9. To add up to 10, or not add up to 10, we already are missing a 6. So one of these must be from a 4, 6 pair. Therefore, 4 has to be here, which means 4 cannot be here. 4 cannot be here. We have 1 out of 3 or 7. We have 1 out of 2 or 9 with a 1, 8, or 8 here. We're not sure which one. 4 obviously has to be here. Okay. Where is 5 in column 1? It can't be here because it can't be in the 7 cage, and it can't be here. So it must be here. So this is 5, this is 6. This can't be 6 here. So one of these 2 is a 6. That's fine. 5 has to be one of these 2 digits here. You can't have a 9 here, and you have to have 1 each out of 1, 8, 2, 7, 3, 6 in the 4, 5 pairs. Okay. 5 can be... It's any of these 3. Where's the 5 in box 2? It cannot be here because this is it cannot be with the 3 to add up to 8. Can't be here. Can't be in this box because that would be with the 2 to add up to 7. So it must be here. So this is 5. So 5 is here, which means 5 can't be here. This can't be 5 here. 5 is one of these 4. 5 could be here. We don't know which. We have 4 and 5 already in this pacifist 10 cage. If we had a 1, that would add up to 10. So this can't be 1. This has to be 8, which makes this a 1. 8 is in this cage, which means 2 cannot be in the cage because that would add up to 10. So this can't be 2. We have 1 out of 3 or 7 here. So 2 has to be one of these two. 9 has to be the other one. Because otherwise 1 and 9, we don't have 1 out of that set there. So 9 has to be one of these. So this can't be 9. 2 has to be one of these 2. 9 has to be one of these 3. This has 1 out of 1 and 9. So the 9 is here. The 2 is here. The 4 is here. So this can't be 2, 4, or 9. This is 1 out of 3 or 7 is here. It's because you can't have both 3 and 7 here. There's no combination of 2, 3, 4 or 2, 3, 7 that adds up to 10. We already have an 8 and a 9 here with 5, 4, and 1 out of 3 or 7. We're not sure which. Therefore, 9 has to be here. 4 has to be here. So this cannot be 4 or 9 here, which we know are part of the this 10 cage. Same, 4 is also here, so this can't be 4. Again, 9 has to be one of these. 4 has to be one of these. Therefore, this must contain a 5. Because there's no other digit, because we have 8, so 8 has to be one of these. And we have to have 5, and then the other 3, 7 here. So 8, 3, and 7 have to be here. Because 4 and 9 both have to be here. 4 and 9 both have to be here. This is also 9, actually. So this is 9, and it also has to be 2. So 2 and 9 cannot appear in the rest of this box. We have 1 out of 3 or 4, and we have a 6. So we need another digit. So this must be 8. So this is 8. This, we don't have any restrictions right now. Okay. So 8 does have to be here, and 1 out of 3 or 7 is here. 8 can't be here, 8 can't be here. So 8's one of these 4, 8 is one of these 4. Doesn't tell us much. 6 is one of these 3. No, never mind. We have a 3, 4, 7, 9 quadruplet in column 8, which eliminates 3, 4, 7, 9 in the rest of the column. Therefore, this must be 2, 5, 6, and 8. Well, since 2 has to be here, this cannot be 2. And we have 5, 6, and 8 here. 2 is also not in the 10 cage, so 2 can't be here. This 6 is not in the 10 cage, so this is 5 or 8. Also, we know 9 has to be one of these two, so this can't be 9 here. So 2 is one of these 3. 8 has to be one of these 3 also. 8 cannot be here because of the 8 in the row. We know we have a 4 here, so 4 cannot be here. What are the possibilities here? This has to be 9. 1 out of 3 and 7. It cannot be 4, or it's 5. It cannot be 8. So those are the possibilities for these cells. So this is 6, and we have 1 out of 3 or 4 here. which must be the same as that digit. Ah. So this 3 or 4, okay, so this is 6 and it's 1 out of 3 or 4. That means it can't be here. It has to be the same one here, right? If it weren't, the problem is that where would this 3 or 4 be? I mean, no, it has to be the 3 or 4. The 3 or 4 that's in this cage, this pacifist cage, which is not with the, which is, we need obviously one from 1, 6, one from 2, 5, and one from 3, 4. The one from 3, 4 has to be here, right? To match with the 9 and the 6 and the 2, right? The 6 is the one from the 1, 6 pair. The 2 is one from the 2, 5 pair. We need one from the 3, 4 pair so that we can have 5 digits here. So this is 3, 4. This is that 3, 4. Where is the 3, 4 in column 3? It has to be in box 7. And therefore, this must be a 3 out of 3 or 4. So this has to be 3. It cannot be 4. So this is a 2, 3, 9 triplet. This can't be 4. This is a 3, 6 pair. That eliminates 3 and 6 in the rest of the row or column. This can't be 3. This can't be 3 because one of these is 3. This can't be 3. Therefore, this is a 2, 4, 7, 9 quadruplet here. This is 3, so this can no longer be 3 here. This can no longer be 3. Therefore, this has to be a 3 here, which eliminates 3 in the 7 pacifist cage. So we cannot have a 4 in there. Where is the 4 in box 2? Cannot be in this pacifist cage. It must be here. So since 4 has to be here because it can't be in this 4 pacifist cage, because that adds up to 4, therefore one of these two is a 4. This cannot be a 4 here. So 4 has to be here, which means this can't be 4. This is 7, which eliminates 7 here. This becomes a 2, 4, 9 triplet. That makes this a 5, 7 pair here, which eliminates 5 and 7 in the rest of the column. This can't be 7. This 7 eliminates 7 here, so this is 4, which means this can't be 4. We have a 2, 8, 9 triplet in row 1, which eliminates 2, 8, 9 in the rest of the row, so this can't be 2 or 9. This must be 3. That means this can't be 3. This is a 2, 9 pair here, which eliminates 2 and 9 from here. This has to be an 8 because of the 2 and 8, 9 triplet. That eliminates 8 here, so this is 1, this is 8. This 3 eliminates 3 here, so it's 7, which means this can't be 7. This has to be an 8, so this cannot be 8. This must be 6 then. 6 can't be here. This is 4. It cannot have a 7. Where is the 7 then? We have to have a 1, 7 pair here. It must be one of those. We know 3 has to be one of these 3 digits here, which means this cannot be 3 here. Two or 9 is here. We have a 6 here. We have an 8 with 2 or 9 here. Two is one of these two. 2 is one of those two. 9 has to be one of these 5. Where is the 1 in box 6? Can't be here because it's not in the 10 cage, and 9 is already there. So it has to be here. So 1 cannot be here or here. So 1 has to be one of these 3. That's interesting. Where is 1 in box 8? It cannot be here, so it must be one of these 2. Okay. What digits are here? We have 2, 3, 4, 5, 6, 7, 9 as possibilities. 5 cannot be here. 6 cannot be here. This can't be 5 either. Okay, so 5 is not in this 9 cage. We need one out of the 4, 5 pair to be in this 9 cage. Otherwise, we don't have enough pairs, right? We'd have 1, 8, 2, 7, 3, 6, or 4, 5. 5 has to be one of these 3. Therefore, 4 must be in this cage. So since 4 is in this cage, this cannot be 4. 5 is one of these 3. 4 cannot be in any of these. You can't have 2, 3, and 4 there. Hmm. So 4 has to be one of these 4 digits here. That doesn't tell us very much. 1 has to be one of these 2. um, what else do we have? Three, 4, and 5 add up to 12, so that's fine. And 3 doesn't add up with any other number besides 7 to add up to 10. One out of 3 or 6 is here. We don't know which. Hmm. If this is not 7, say this was say 7 was here. If 7 is here, that forces this to be 2. That would force this to be a 4, 7, 9 triplet. But the problem is 7 would also have to be here, right? Because it would be a 7, 8 pair. So again, if this is 7, this is 2. That forces this to be a 4, 7, 9 triplet. 7 can no longer be here. 3 can't be here either, right? So that would eliminate all possibilities for this cage, right? Because you already missing 4 and 9. You can only have, you have a 5 and an 8 left. So 5 and 8 are both here. And the one that's from 3 or 7 has to be here. So this can never be 7. This has to be 2. No, other way around. This can't be 7 here. Because again, if this is 7, that forces this to be 2. This is 4, 7, 9. This can only have 4, 5, 7, 8, 9 in this cage, because anything else adds up to 10. So, and this can't be 7 though, because of this 7. We're missing we have a 4, 7, 9 already here. So this cannot be 7. This has to be a 3, 4, 9 triplet, which makes this a 3, 8 pair. Therefore, this can't be 7. This 3, 4, 9, this eliminates 3 here. This is 3, 4, 9. This has to be a 5, 9 pair, which eliminates 5 and 9 from the rest of the box. So this must be 8. This can't be 8 or 5. This can't be 5. These can't be 9. So since this can't be 9, this is a 3, 4, 7 triplet, which eliminates 3, 4, and 7 from the rest of the column. So this can't be 7. This is 2. This is 7. This 2 eliminates 2 here, so that's 9, which makes this a 2. This 9 eliminates 9 here. So this becomes a 2, 3, 4 triplet, which eliminates 2 here. So this is an 8, 9 pair. This is 3, 4, 7. 2 and 6. 8 is here. So 8 has to be one of these 2 digits here. 3 cannot be here. 3 cannot be here. Where is this? This can't be 2. So this has to be a 4, 7, 9 triplet. Where is the 6 in box 8? Can't be here, can't be here, can't be here, can't be in the cage, because that would add with 4 to add up to 10. So 6 must be here, which makes 1 here. 1 cannot be here, so 1 has to be in the cage. Because 1 can't be here, 1 can't be here. Therefore, 8 cannot be in the cage, so 8 has to be here. Which means this can't be 8, this is 9, which makes that an 8. 9 cannot be here or here. So 9 has to be one of these 2 digits, which means this can't be 9. 5 is one of these 2. 4 is with, 4 can't be here because 4 is already in the cage. So 4 is either here or here. We have 1 and 4 already in the cage. We have 1 out of 2 and 7, 1 out of 3 and 6 in the cage. We're not sure which. This can't be 6, so 6 has to be one of these 3. Six has to be in box 4 in rows 4 or 5. And in box 6, it has to be in rows 4 or 5. This 2, 6 pair eliminates 6 here, so this is 5, this is 6. So because 6 is in rows 4 and 5, in boxes 4 and 6, it cannot be in the rest of rows 4 and 5. So this cannot be 6. And this can't be 6, which means 6 has to be here, which means 3 cannot be in the box. So 3 has to be outside the box. So this is 1, 2, 4, and 7 as possibilities. Obviously, this can't be 1. And this has to be outside the box is 2, 3. Well, 2 has to be here because that's the only place left in box 8. So this can't be 2. This can't be 2. This can't be 2. We can not have a 1 here. We can't have 2. Could be 3. Cannot be 4. Could be 5. No 6. Could be 7. Cannot be 8 or 9. So this can't be 9 here. One of these is a 5. So 1 out of 2 or 7 is in this box. We're not sure which. Okay. Well, if it is 7 in the box, 2 has to be here, which means this is 4. 7 cannot be here, so this would be 7. So you'd have 4, 7. This would also, since this is 2, this would have to be 6, and this would be 3. That seems like it works. 3 is outside the box, certainly. you know 1 is in the box, you know 6 is in the box. If you had a 2 in the box, 1, 2, and 6 would add up to 9. So 2 cannot be in the box. Therefore, it is a 1, 4, 7 triplet, which eliminates 1, 4, and 7 in the rest of the box. So this cannot be 7, it has to be 2 and 9. That eliminates 2 and 9 in the rest of the row, so this can't be 2, this is 4, this can't be 2, so it's 6, which makes this 2. This can't be 2 or 4, so this is 9, which forces this to be 2. The 6 eliminates 6 here, so it's 3, which makes this 5. This can't be 3 or 4, so this is 7. This can't be 7. This 5 eliminates 5 here, so it's 3. 3 eliminates 3 here, so it's 4. 4 eliminates 4 here, so it's 2. This can't be 2 or 4, so this is 3. 4 eliminates 4 here, so it's 7. 2 eliminates 2 here, so it's 9. This is 2. This cannot be 9. This 3 eliminates 3 here, so that's 6. 3 eliminates 3 here, it's 4. This is 3. 4 eliminates 4 here, so it's 7. These can't be 7. This 7 eliminates 7 here, so it's 1. Which makes this 7. This 2 eliminates 2 here. This 9 eliminates 9 here, so it's 5, which makes this a 9. This 5 eliminates 5 here, so it's 7 and 5. This 7 eliminates 7 here, it's 4. This can't be 4 or 7, so this is 9. 1 eliminates 1 here, it's 4 and 1. Okay. This 1 eliminates 1 here, so it's 8, 1. This 8 eliminates 8 here, so it's 3, 8. 3 eliminates 3 here, so it's 4 and 9, and this is 3. Then 4 and 9 eliminate 4 and 9 here, so that's 2. This 7 eliminates 7 here, so it's 9. This is 7, this is 4. This 9 eliminates 9 here, so it's 2 and 9. 3 eliminates 3 here, so it's 4 and 3. And that's how you solve it. Not too bad, I guess. It is hard, but that's maybe because I haven't done very many anti-Killer Cage Sudoku. I've done a small amount, but not too many. So, and you needed to know Fistomefel's theory to basically understand this part. Otherwise, I don't know how you would get this break in. That would be very difficult. So yeah, I think hard is an appropriate difficulty level for this puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.